These are the frequently asked questions for pre-calculus for section 3.2, day 2. And it's quite possible now that we went over one of these in class that you don't necessarily need these so much, but I'll go ahead and take care of them anyway. In exercises 23 to 26, find the logistic function that satisfies the given conditions. So in number 25, this one is talking about a population, but it is a logistical function. So I'm just thinking ahead to using maybe population according to time, because that's usually what we do for population. And that'll be C over 1 plus A times B to the X. So information that I need. First, I would really like to figure out what A is. To do that, I need to have that C value. And they're telling me that maximum sustainable population is 128. So I can put that in there right away. Now, I know that the initial population was 16. That means that 016 is a point that shows up when you do the math on this. So 16 has to equal our 128 over 1 plus A times B to the 0. Well, B to the 0 is 1. So this is really 16 equals 128 over 1 plus A. And then what I would do is make this proportion and cross multiply. So 16 times 1 plus A equals 128. Divide both sides by 16. So 1 plus A equals 8. And then subtract 1. And A is 7. So now I have an additional piece of information that I needed. I have P of T equals 128 over 1 plus 7 times B to the X. And now I need that B to the X piece. Another piece of information that we had on this, and that was that the point 532 is in this function. So what we want to do is put that 32 in for our P of T. And then we're going to go ahead and put that 5 in for X and solve this, much in the same way that we just got done figuring out what we needed before. We're going to go ahead and slap a 1 underneath it, and then we will cross multiply. So 32 times 1 plus 7, B to the 5th, equals 128. We would divide both sides by 32, and 128 divided by 32 is 4. Then we would subtract 1 from both sides, divide by 7, and take the 5th root. Now, we won't be able to do anything fancy with this. By that I mean we're not going to be able to write this with one base because we have a 3/7. In the past, and in the next problem that I'm going to do, we do have a 1 in our numerator, and that means we can do this a little bit fancier and a little bit exact. But in this case, we would just have to punch it in, figure out the 5th root of 3/7, which is approximately 0.844. So we can finally finish it up. We know that upper limit is 128. We know that A is 7, and now we know that B, whoops, use a T here since it's population. Now that we know that, we have everything that we need. We have C over 1 plus A times B to the T in this case. And again, nothing fancy we can do with this one. We could not make this more exact, and that's because our numerator in this case was not a 1. In the next problem it will be. So that would be a problem where we would want to see it both with the decimal equivalent and then as an approximation, and then we'd want to see it exact. And that's number 27. So for number 27, I can see that my asymptotes are at 0 and at 20, and that 20, that's my upper limit. That's that limit for the population, the sustainable limit for growth. That is C. And I want to start this the same way I did the last one, where I'm thinking ahead to, I don't know what this is. I don't know if it's population. I have not a clue. So I'm going to go ahead and put f of x is there. And then 20 is my C value for on top, and I need 1 plus A times B to the X. I'm definitely going after that A first because I can see right here that 0, 5 is part of this graph. So I'm going to put a 5 in for the Y and put a 0 in for X. And of course, anything to the 0 power is 1. So that will just give me 5 equals 20 over 1 plus A. slap a 1 underneath and do some cross multiplying. And then we can divide both sides by 5 and subtract 1. And we get a nice value for a of 3. So we go back and we think, well, what do we know so far? Well, we have f of x equals 20 over 1 plus 3 times b to the x. But there's another piece of information we haven't used yet. That's the 2 and the 10. So 10 equals 20 over 1 plus 3 times b squared. We're putting that 2 in for x. Again, slap a 1 under there, do a little cross multiplying, and start to solve. Divide both sides by 10. We have 1 plus b squared, 1 plus 3b squared equals 2. And then we would subtract 1 from both sides, divide by 3, and then we would take the square root. So now, this is one where we are going to have choices. First of all, we could just punch it in and find the square root of 1/3, and that is 0.577. So that's a good approximation. But I also recognize that the square root of 1/3 is the same thing as 1/3 to the 1/2 power. And then 1/3 is the same thing as 3 to the negative 1 raised to the 1/2. And that will be 3 to the negative 1/2, because when you raise a power to a power, you multiply. So for an approximation, this would be good. But for an exact answer, this would be better. And again, I'm going to show you this both ways. So first we'll go with the approximation. F of x equals our 20 over 1 plus 3, and then we had 0.577 to the x. So that's with the approximation using the calculator to find the square root. And then we would also have f of x equals, and this one would be exact, 20 over 1 plus 3 times 3 to the negative 1/2 to the x power. And with this one, we'd focus on the fact that we have to follow the order of operations. And when we do that, a power to a power takes precedence here. So if we have negative 1/2 an x, we're raising to a power, we're going to multiply that. And that will give us negative x over 2. And now that we have that taken care of, and let me make that a little larger so it doesn't look so squished there. There we go. All right, and now that we have that taken care of, we can see that we have a base of 3, and it's being multiplied together. So we want to remember that that is a little imaginary 1 there, and when you multiply similar bases, you add the exponents. So that would really be 3 to the negative x over 2 plus 1. And this would be an exact answer. We talked about in class that with free response, it doesn't matter whether or not you have the exact answer or the approximation, but you also, so this one would be just as good as this one in a free response. But for multiple choice, you have to be able to use both of those to understand that this is the same solution, just algebraically better. I mean, definitely if we're talking about elegant answers, this is definitely more elegant than using that approximation for the decimal.